For the max, I'm just going to reuse the min implementation, but I'm going to propagate the bigger value instead of the smaller. So I rename that to max, open it, and say, okay, I just want to keep the bigger of the two of them. So if the accumulator in is bigger than V, then it's the accumulator in, else it's V. Okay, good. Okay, and I'm going to copy this and use the max instead of the min. Okay. Now I need a mean implementation. So let's say I want to take the mean between the maximum value and the minimum value. Okay. So let's create a new mean operator, and for its interface I want it to take two code T's and return one code T. So two values, two inputs and one output, all of them being of type code T. And let's call that A, let's call that B, and let's call that M. That's going to be the mean. So let's implement this. Okay. To implement the mean, I need to add those two. Good. I'm going to display the types to make things clearer. So this is a code T, and my output here is a code T. So now I need a division, and I do have two divisions available in SCADE. I have the real division and the integer division. The real division takes two code T's and returns a real, while the integer division takes two code T's and returns an integer. So I'm going to have a problem. Can I do a division that takes two code T's and returns a code T? Today, this is not available in the current SCADE language. While we're going to add it in the next language revision, I need this implementation to work now. So I will use a specific feature of the language, which is the specialization. I will specialize the mean operator. Specialization, if you want, is the poor man's genericity. So I'm going basically to create an empty interface for the mean. So I'm going to cut this, okay, and declare this as imported. Basically, if it's imported, it has no definition. So I can use this mean here. So it's empty for the moment. I have no interface, okay? But I can use it and verify that the internal types, that the type it takes two code T's and returns a code T. Now, of course, if I want to generate the code for this mean is going to be empty. Okay, so that cannot work. What I can do is basically to provide specializations for this mean. Okay, so I'm going to create two implementations because I know that code T is either an int, either a real. So I will provide an implementation for each possible type. Okay, so let's do that. I'm going to create an operator min int, for example. I'm going to pass what I had. I want to use the integer division, divide by 2, okay, and on the min int, I say that everything is an integer. Okay. And now what I can do is say that this operator specializes this more generic operator. Okay. Good. I'm going to do exactly the same thing for the real. Okay. but instead of using an integer division, I will use a real division and divide by a real number and ensure the interface, everything is real. Good. Okay, my interface is not in the right order. Okay, here we are. So I can then check here. So I have a couple of issues. The first thing is those are functions, okay. And the median is seen as having an internal state. It's because this mean is seen as a node. So you cannot know that there is no memory. I say there is no memory here. So I can check this, no error, good. So let's have a look at the behavior now. I'm going to simulate this, save my changes, generate the code, compile it, and link my simulator with it. Okay. So I'm going to put some values, let's say a minimum value here like -10, a maximum value like 255, a couple of other values in the middle. So those okay, and for this one okay, good. I'm starting to get bored of typing numbers here, so I'm just going to save this into a scenario. Let's name that test case 001 and I save it. I need to do one step first and save it. Okay, good. So let's see if it works properly. So in that case, my max is 1, 2, 3, 4, and my mean -10. And the mean of these two values is 612. Okay. For this one, the max is 99, the mean is -5, and the mean is 47. Good. And for the last one, the mean is 1.1, the max is 8.8, so the mean is 4.95. That's good. Excellent.